Morning. How was your vacation? So nice to meet you. I'm Gyeongsik, and this semester we will study reinforcement learning, and today we will finish early, like 10 or 15 minutes maybe. I'm just trying to introduce today this semester's course, organization, and some requirements. And any questions, if you have, feel free to ask any questions. As I said, I'm Gyeongsik. I'm in computer science department and teaching assistant. I'm still talking with department. It's not decided yet, but maybe one or two TAs might be assigned, I think. And there are some basically there are some recommended prerequisite courses like linear algebra, basic programming, statistics, and AI. I guess this is for third or fourth year students. So I guess most of you guys already took this course. And these are some summarized goals of this course. So basically we will cover a wide range of topics of AI for robotics, which is called physical AI these days. And there are three goals. So the first one is understanding 3D rotation, transformations, and forward inverse kinematics, in short FK and IK, to mathematically define the physical state and action spaces for RL agents. And the second one is designing RL algorithms suitable for continuous robotic control and acquire the ability to train optimal policies for task execution in simulation environments. And finally, grasping the principles of visual language action models, VLA models, and implement next-generation robotic systems capable of executing complex instruction by integrating multimodal data. This seems really ambitious. It seems like if we finish all these goals, maybe you can get a very expert on this field. So I actually, to be honest, I do not expect all of you guys can achieve these goals, but if you can just achieve half of this expectation, I think it'll be successful for you. So in short, so basically the name of this course is reinforcement learning, but I actually do not try to constrain in reinforcement learning because these days, beyond reinforcement learning, many things are introduced to implement AI for robotics. So I will try to introduce, of course, RL, but some additional things like, so basically basic 3D knowledge, basic 3D concepts, and these days popular VLA models as well. So this course will cover a wide range of topics of AI for robotics, literally. And in one sentence, the goal is making your own agent driven by your own policy networks or VLAs in physical space that can interact with work. That is goal of this course. And these are some organization. So all content will be self-included. That means you do not have to purchase any textbook. But if you want, you can study this textbook, Reinforcement Learning and Introduction, second edition by Richard Sutton. And you can study computer vision focused on 3D with my recorded lectures. So in previous semester, I lectured a introduction to computer vision, which is focused on 3D stuff, mainly 3D stuff. And this is available in YouTube channel, so you can watch my recorded lectures to study some basic 3D representations and 3D concepts if you're not familiar with them. And all lectures will be recorded and uploaded to LMS. And during the semester, videos will be uploaded only to LMS. And after the semester, all lectures might be uploaded to YouTube. So if you want to study again, then you can visit LMS or YouTube, anything. We will have several programming assignments, midterm exam, final project, and final exam, very typical organization of CS courses. And these are some scores of each stuff in the organization. The attendance, I will not try to give scores for attendance, but according to university's policy, you need to attend at least 2 over 3 of the class, otherwise you will get an F grade following university's policy. I do not have any authority on this. I just need to follow university policy. So you need to manage your attendance. You need to at least attend at least 2/3 of the class. And assignment, 10% assignment. Easy implementation. Just to make, I guess most of you guys are not familiar with the physics simulator, Isaac Stream, Isaac Labs. So I just want to make you get familiar with this RL and physics simulator. So the assignment 10% will be just for this purpose, just make you get familiar with basically RL and physics simulator. And midterm final exams, 30% for each. I do not prefer a memory-based test, so you do not have to memorize all details, but the test might be in closed book test, so you need to understand them. And of course, using AI during the test is prohibited. And the final one is final project, 30%. This might be challenging. So as I said, I actually encourage you to use AI services when you study or when you do assignment, when you do final project. But so that is the reason why I'm trying to make final project difficult and challenging. Although you use AIs, I guess this might be not easy, final project. So final project might be a little bit challenging, but I strongly think you will learn much from it. So making your own physics agent in physics simulator with RL, that might be the goal of the final project. And you might need lots of computational resources. I will talk this later, but some of computational resources, I got support from AWS from the department, but I do not think this might be enough. I will talk this later. Is it clear? Anything you want to ask about this? And this is just a screenshot of iJob Lab, NVIDIA, which is from NVIDIA, just physics simulator, the most widely used physics simulator. And as I said, this course is for 3rd or 4th year undergraduate students interested in robotics and AI, students familiar with deep learning frameworks and interested in robot control theory. But if you are 1st or 2nd year students, please reconsider taking this course and consider taking more basic courses instead of this course. I strongly recommend withdrawing this course and just take basic courses. Anybody first or second year students? Okay, good luck to you. And this course utilizes NVIDIA Ajang Lab, a high-performance physics engine. Therefore, a personal PC equipped with the NVIDIA RTX 3060, 8GB free RAM or higher GPU is mandatory. Please note that if this requirement is not met, it will be physically impossible to complete labs and assignment, including final project. Please strictly take this into consideration when registering for the courses. I actually wrote this in Syllabus, but recently I got support AWS GPU environment from department, but assignment to students could be limited. There are many students. Even now we have more than 70 students, and maybe more students might want to register this course. So I can't provide all the AWS environment to you, although I tried my best to get support, AWS GPU support from department, but we have some limited budget, so I cannot assign all the AWS computational resource to you. So actually, I strongly recommend you to having some your local computational environments. Anybody, do you have any local competition environment which is similar or better than RTX 3060? How many of you guys have this local computational environment? Could you raise your hand if you have? Okay. It seems less than half students have this competition environment. But if you, I just recommend you just buy this. If you want to study CSE, I think this kind of some competition environment is necessary. So I know these days this kind of computing resource is a little bit expensive. But if you want to study further, then I think you need this kind of computational resource. So I strongly recommend you have this kind of low computing environment. So as I said, I keep saying the same thing 3 times. Hence, local computing is recommended. But if not available, you can utilize provided AWS GPU environment. Although there can be usage time limit, and I cannot provide all the computing environment to you. Very selectively, I might provide you. So please note this. And as I said, we actively encourage the use of generative AI tools, including ChatGPT, Gemini, and Cloud to enhance learning efficiency. Of course, however, the use of AI during examination, midterm, final exam is strictly prohibited. You can use this AI. Of course, if you can study this, implement the assignment, the final project without any help from generative AI, then it might be perfect for you. But if you feel, struggling this kind of assignment or project, you can use them. But do not rely them too much. You need to understand the overall structure, although you have support from this kind of generative AI tools. I think you understand what I mean. And today, now let's begin with warning. So as I said, this course will be extensive and intensive and requires computing resources. This is not for beginner. This will be very intense. So while the department provides AWS access, students are solely responsible for any disadvantages caused by its limited usage time and assignment, because I do not have any authority. But I understand maybe we can compromise, and if I can just give a very easy final project, then maybe most of you guys will not suffer from this kind of limited GPU environment. But I want you to learn much from this course, so that is the reason why I'm trying to make the final project a little bit difficult and challenging. And in this situation, then enough amount of computing resources is mandatory. So that is the reason why we have might be some limited usage time and assignment for the GPU environment. And therefore, it's highly recommended to establish local computing environment if possible. And if such requirement seems too harsh for you, please reconsider taking this course or consider withdrawing this course. So nothing is decided. I got confirmed that I will get GPU support from the department, but I do not know how many students can get support or how much usage time for students can use such kind of GPU environment, because we have lots of students and the number of students is not fixed yet, right? So the beginning of semester there are many changes. So some students try to withdraw this course, some students try to register this course. So we do not have fixed number of students. So nothing is decided yet. But I got confirmed of the GPU environment support. But as I said, nothing is decided yet. How many students can get support? How much usage time we can get? So that is the reason why I just recommend you get local computing resources. Or your own private AWS, that is also good. And this is contents of this course. So we begin with introduction. And so basically we first study some, this is overlap with my previous computer vision course, like 3D, basic 3D concepts, 3D rotation, coordinate system, and forward inverse kinematics, water force inverse kinematics. And why do we study this kind of robotics? And what is difference between reinforcement learning and previous? There are many types of learning strategies, right? Supervised learning, weakly supervised learning. There are many strategies for learnings. So what is difference? What makes it difference between reinforcement learning and other types of learning strategies? And why do people try to use RL for the robotics? Why can't we use supervised learning for robotics? This kind of basic concept we will study 1/3 of the semester. And then we will study like some kind of classical RL before midterm. And these are some these days, recent algorithms, PPO, soft actor critics, and VLA. This is the all companies trying to do this, build their own VLA these days. So what is the VLA, and what are challenges, and sim to real? How can we make physical agent in simulator to real environment? How can we transfer the environment to real environment? So these are contents of this course. And that's it for today. Any questions if you have? You can use Korean if you have any questions. So what's your plan? I mean, are you going to have your own local computing resources, or anybody have concrete plan for getting your computational resource, or just withdraw a course? I mean, it's not bad withdrawing this course. I mean, but if you want to learn many things, I mean, these days, especially, this kind of physical AI and this RL robotics seems very important. So personally, I actually want you to study this one and just with your own local computing resources. But there can be some situations for each student. Some students might have some problems with their budget, so they can't get their local computing resources. Okay, go ahead.
Like if we buy our own like AWS, you recommend us to like buy throughout the semester or like after the midterms, like during the final project?
So the final project will be assigned after midterm, but we will have the assignment. There were 10% assignment, right? That might not be challenging, but that also requires Isaac Zim or lab environment. If you have, but that might be not very extensive. So if you have some kind of local computing resource, like your laptop, I'm not perfectly sure, but that might not require heavy computational resource. So I think you can use your laptop until midterm, and then after midterm, you can use your own local computing for the final project, I guess. Is it okay? Any more questions? So my just opinion and recommendation is starting this with your local computing. But I understand there are many situations for students to understand everything. Withdrawal is okay. Everything is okay for me. Okay, if you do not have any question, let's finish today. Thank you.